Hi, we introduced stylized tensorial radiance fields, a method to stylize radiance fields in less than a minute.
Given a sparse set of input images and a reference style image, a task is to create a 3D scene representation with the reference style image applied to it. We use radiance fields as our underlying representation. For every point in the 3D space and for a given viewing angle, radiance fields give the color of the point. Recently, a lot of works have utilized radiance fields coupled with volumetric rendering. NERF uses a multi-layer perceptron to approximate the radiance field. Tenoxils divides the scene into a sparse voxelized grid and stores spherical harmonics coefficients at every vertex. TensorRF also represents the scene as a volumetric grid but uses tensor decomposition for compactness. Recently, some attempts have been made in stylizing radiance fields. Chiang et al. Proposed to stylize NERF's MLP with a hypernetworks output. However, the results are inconsistent in the frame due to the patch-based approach. SNERF proposes an iterative training strategy which involves optimizing NERF's training input and retraining NERF 3 to 5 times. They produce blurred geometry and take 3 to 5 days of training. Stylized NERF proposes 2D 3D mutual learning to stylize the NERF MLP. They suffer from fused geometry and disproportionate style transfer. Our approach uses TensorRF to represent radiance fields and just takes 40 to 50 seconds to fine-tune any pre-optimized scene to any pre-trained style. We maintain the geometric details and transfer style onto the geometry proportionately. We use the approach proposed by Johnson et al. To adapt an image stylization module to a style using the COCO 14 dataset. This roughly takes 20 minutes. Once this is done, we can infer stylized images with speeds up to 30 images per second. Additionally, we can store multiple such pre-trained networks for different styles. Concurrently, we optimize a TensorRF representation for our underlying 3D scene. This takes 15 minutes. With this, we can now generate real-world novel views for our scene. We pass the generated novel views through the pre-trained image stylization module for a particular style. With this, we obtain a strong stylized prior for the appearance optimization. We freeze the density parameters in a TensorRF and then fine-tune the appearance values for 1000 iterations, which takes 40 to 50 seconds. Now we can use standard volumetric rendering techniques to generate stylized novel views. Now we show the results. The styles in the bottom row will be applied to the scenes on the remaining rows. Thank you.